All right, here's a little more practice with the stoichiometry of limiting reactants. So again, it is so much to learn. I hope you're not doing this in one sitting, and I hope you remember this from your biochem/chemistry class. So the purpose of the limiting reactant is to say, well, if I have this much of each reactant, how much product could I make? You figure out how much product you can make starting with each of the reactants, and then the one that makes the least is your limiting reactant, and that's your theoretical yield. So, let's see. In this problem, I have 10 grams of barium acetate, trying to see how much barium sulfate I can make. So, starting with the 10 grams, I'll see how much barium sulfate that makes. And starting with the 8 grams of aluminum sulfate, I'll see how much that makes. So I'm going to go from grams of this guy to moles of barium acetate, and then moles of barium acetate to moles of barium sulfate, and then moles to grams. And then I'll do the same thing, but starting with the aluminum sulfate, and whichever makes the less barium sulfate, that's going to be my limiting reactant. Okay, I bet you anything you are going to know acetate is CH3COO with a 1- charge by the time you are done writing this out. That's the good part. Sorry. It's a lot of work to start with. But I promise if you guys show up knowing stoichiometry and dimensional analysis, it becomes not that bad. But if you don't know this stuff, it's like, what is that voodoo she's doing all year long? You can ask my kids that never learned it. So, barium acetate, BaCH3CO2 with a 1- charge, so 2 acetates. I start with the grams, and since I have grams of barium acetate has to go on the bottom. And I'm going to find out how many moles that would be. So I'll go from grams of barium acetate to moles of barium acetate. And the way they're related is through molar mass. So I'm going to find out how much 1 mole of barium acetate weighs. I use periodic table, add them all up, and I've already done that, so it's 255.42 grams of barium acetate for every 1 mole of barium acetate. And then, since this is what I have, it's the unit that goes on the bottom, moles of barium acetate. CO2, CH3CO2. Okay, so I'm going to go from moles of barium acetate related to what I want to know about, which is moles of barium sulfate. Why did I pick acetate? It's so long to write. Okay, so 3 moles of this for every 3 moles of that. That'll tell me how many moles of barium sulfate I'm going to make. And then I want to know how many grams that's going to be. Whew. So the unit I have here, moles of barium sulfate related to grams of barium sulfate. All right, and they're related with the molar mass. So I added up 1 barium, a sulfur, and 4 oxygens to find out that 1 mole of barium sulfate weighs 233.39 grams. All right, so then when I type this in, I'm going to type in 10 divided by 255.42 times 3 divided by 3 times 233.39 grams, and I get that the barium acetate is enough to make 9.1 grams of barium sulfate. Let's see how much barium sulfate the aluminum can make. So I start with 8 grams of the aluminum, Al3. Sulfate is SO4 with a 2- charge. Oops, sorry, it's Al2, SO43. Okay, because their charges are kind of swapped. So I have grams of the aluminum sulfate. And I'm going to want to find out how many moles that is so I can relate it to the barium sulfate. So 1 mole of aluminum sulfate. Find out how many grams that is. It's 342.14 grams for every 1 mole. That gives me moles of aluminum sulfate. The balanced equation tells me that 1 mole of aluminum sulfate reacts with for every 3 moles of barium sulfate that form. And the molar mass will tell me that 1 mole of barium sulfate has a molar mass of 233.39 grams. All right, so I will type that in, and I'll say 8 grams divided by 342.14 grams tells me the moles of aluminum sulfate. Then I'll multiply by 3 because for every 1 aluminum sulfate I make 3 moles of barium sulfate. And I'll multiply by 233.39 because for every 1 mole of barium sulfate it weighs 339 grams. So this reactant is enough to make 16 grams of barium sulfate, which means I run out of barium as soon as 9.1 grams of barium sulfate have been made. There's no more barium, so I can't continue on to make that much, right? So barium acetate is my limiting reactant. The aluminum sulfate would be in excess. I have extra of it. It's my excess reactant, and my theoretical yield is 9.1 grams. Okay, so I have one more limiting reactant problem for you guys. It uses molarity. Woo. And then, that's pretty much everything. Oh, I have to talk about energy too. Energy will be the last one. Okay, so how many grams of barium sulfate could precipitate starting with 250 milliliters of 2.5 molar sodium sulfate and 200 grams of barium acetate? So you have information about the barium acetate, and you're asking for grams of this, so we'll have to go moles of barium acetate, moles of barium sulfate, grams of barium sulfate. Then we'll do the same thing, but starting with the information about the aluminum sulfate. We'll find out how many moles that is, relate the moles of this to the moles of that, barium sulfate, and find out how much barium sulfate each reactant can make. The one that makes less is the limiting reactant, and that'll tell us our theoretical yield. So let's start with the harder part, the molarity one, or the new part for us. So we have 250 milliliters. Hopefully you don't mind me saying there's 1,000 milliliters in 1 liter, so I can just move this decimal back 3 times, and that is 0.25 liters of aluminum acetate, Al2 SO43. Okay, so that's how many liters of aluminum acetate I have. And this molarity tells me that for every 1 liter of aluminum acetate, there are 2.5 moles. That's what 2.5 molar means. It means 2.5 moles for every 1 liter. So 2.5 moles of aluminum acetate, or sorry, sulfate. Sulfate is SO4, and has that 2- charge. Okay, so that tells me the moles of aluminum sulfate. Then I can relate this to this, because 1 mole of this is used for every 3 moles of that are made. So 1 mole of aluminum sulfate is used for every 3 moles of barium sulfate that are made. And then, since we're looking for grams, I'm going to have to say how much this weighs. So 1 mole of barium sulfate is present for every 233.39 grams of barium sulfate. That was the molar mass that we already saw. Okay, so I would go 0.25 times 2.5 moles per liter times 3 moles of the barium sulfate for every 1 mole of the aluminum sulfate times 233.39. And when you type that in, we have enough aluminum sulfate solution to make 440 grams of barium sulfate. Let's see how much barium sulfate we make starting with the barium acetate. So I have 200 grams of barium acetate, and I'm going to see how many moles that is by relating my moles, or my grams of barium acetate to moles of barium acetate. And that is, let's see, 255, I think it was 0.4 or 0.14 grams of barium acetate for every 1 mole of barium acetate. And then I know that 3 moles of barium acetate react for every 3 moles of barium sulfate that form. For every 3 moles of barium sulfate that form. And then I'm going to want to say, I'm going to want to go from moles of barium sulfate to grams of barium sulfate, knowing that 1 mole of barium sulfate was 233.39 grams. Okay, so 200 divided by 255.14 grams times 3 divided by 3 times 233.39, and I end up having enough to make 183 grams of barium sulfate. All right, so what that means is that I run out of the barium acetate as soon as I've made 183 grams of barium sulfate. So then I don't have any more barium, so I can't make any more barium sulfate, so I won't be able to make the 440. My theoretical yield is 183 grams of barium sulfate. That means my limiting reactant is the barium acetate. The excess reactant is the aluminum sulfate. All right.